So recording should be started now. All right, so it is February 2nd, 2021. This is for the postgraduate program for AI and machine learning for UT Austin and Great Learning, just a study group. Anywho, before I was planning to go through a just from one end to the next building convolutional classifier and just walking everyone through that. Before I hop in, is there anything specific that you guys were had questions about or wanted to understand more of?
I know this is going to sound really crazy and probably really elementary, but you know what I had a problem with? You know how you have the frame and the size and what it would be with after the next filter, what would be the next size? It seems like I had such an issue with that, especially on the test. It's like, what? I thought I was doing the formula correctly, but for some reason.
Okay, that's relatively easy to do.
That's
So,
good.
well, how long ago did you do linear algebra?
Oh my gosh, when I was in college, which was
That would explain
years
it.
and years ago.
So the way to think about, let me see if I can, oh, I guess I could share my screen to make for visual tools.
Okay.
Let me just do CNN filters, just so I can do something visual with this. So when you're performing these operations here, this is just matrix multiplication. So you're doing you're doing element-wise multiplication and then summing them for the pixel. And so the output, just looking at a 1 by 1, or looking at a n by n by 1, it's going to always remain, the output's always going to be the same. You're going to have with getting this a little tongue-tied. Thinking about this logically, if you look at this image here and you've got a 3 by 3, you can see that it's doing one step, one step, one step, one step, and that the output is going to be the equivalent of what this input image is size-wise, because if we look around the edge, you see that there's the padding right there.
Right.
If there had not been that padding, you would wind up with the output image being a n minus 1 by n minus 1 by 1, because this is just a single filter. Now, if you have n by 1 for the image, and then you have 3 filters, you would get one output image for the first filter, plus another output image for the second filter, plus a third output image for the third filter. So assuming it is an n by 1 matrix, and you have 3 filters, you would get 3 outputs.
Okay.
Now, if you have, one moment.
That's fine. I'm going to
Sure.
get.
Because I will admit my linear algebra is not great.
That's
So
okay.
just think of it as that sliding window for a moment, and
Right.
and each filter is going to output its own image in the end. If you have 3 filters by 3 by 3, you wind up with maybe this is a better image for it. That's not right. Okay, maybe that was not a great one to go with. But it's based on what the number of input it's an operation of the filters versus the dimensions or the third dimension of the image, the number of channels. Let me just make sure I didn't get something backwards here. I'm going to move this over to another screen because I need to double check something and I don't. Actually, I'm going to use a different window for that because I want to say it's also, if I do a 3x3 and a 3x3, it's going to wind up with 9 channels, but I want to make sure that I'm not getting something backwards here. Notice how I said it was totally simple, and then I need to double check
I
my.
know, right? But no judgment from me because I'm the one that's like, oh my gosh.
Yeah, it's going to be the output's going to be based. So the output is always going to be you're going to have the same number of filters or the same number of channels in the output as there are filters being multiplied. Make sure there's not. I want to say there's an exception to that when you have where you have an uneven number of where the number of channels doesn't go evenly into the number of filters, and I don't remember the specifics for that case. Let me double check.
Okay.
Okay. Let's just see. I want to say that there's a different calculation, but I want to skim through. Oh, wow. I like this. So I've never been to this site before, but Dive into Deep Learning has the code in MXNet, PyTorch, and TensorFlow, so you can see whatever works best for your use case.
Oh.
Interesting. Yeah, it looks like it's going to be based on the number of filters that you're using then. Okay. Does that make sense?
Yeah, yeah. Kind
And
of.
you don't, so if you're using Keris's sequential API, which is what we're using for our projects and what I'm going to be using for this study session, you do not need to hand calculate the dimensions that the image is going to have during each convolutional step within reason. If you were to say create something that's 40 layers deep and by the end you've gone through enough convolutions that the image shrinks down to a single pixel, then you're going to run into issues, but that's not likely to occur.
Okay.
If you're using, I don't know about Keris's functional API or using TensorFlow by itself, because I haven't done either of those in long enough that my knowledge is not relevant anymore. When I used Keris functional and TensorFlow just by itself, that was pre-TensorFlow 2.0. So a lot's changed there. I've spent more time with PyTorch, and I'm not a genius at PyTorch by any stretch of the imagination, but that's what I've been trying to learn because that's what a lot of people I work around learn or study around learn. Compete? Yeah. Any other questions?
No, that was my main one.
Not for me.
Okay. In that case, I wanted to explain what data set I'm going to be using today. This one is on Kaggle. It is the Alzheimer's. It is a database on Alzheimer's MRIs. So if I look, I'm just going to quickly. So I'll share this link here. This is for a notebook that I did on this data set last year. And this is using a different tool. This one's using Fast AI, but it's just, that's there so you can see in a little bit more detail. Well, you can see some techniques that can be used for it. The data set itself is right here. So I have both links there. So the goal for today isn't to create a model that's going to perform as good as this model does. It's just kind of to go through some of the basics. And these basics, you could use all of the code that I'm intending to do today. You could use for the class project, and I believe it would all function perfectly well for it. But you'd have to use the files slightly differently than how they're set up on the course page. So these files, and I've downloaded them already so I can use them on my machine, are already divided into a training set and a test set, and are in 4 different classes: mildly demented, moderate, non-demented, and very mild demented. And when they say demented, they mean dementia, if that makes sense.
Oh, yeah.
So that's the 4 classes, and because Alzheimer's is a form of is a dementia, or in the same class as dementia. And then there's also the test set as well. So lass uns anfangen. First, make sure I have everything. Okay. Okay. So I'm going to create a new notebook, and this one I'm just going to call practice with CNNs in TensorFlow / Keras. Oh, I guess I can't have a slash there. Okay. So to begin, what I'm going to be, and I'll show you guys what I'm using for reference material. Here we have the TensorFlow API, which allows me to view all of the documentation. I showed you guys this in the previous study session, but I'll include a link here as well. So the first step with deep learning is to be able to load the images into machine readable format. There's many different ways there's a few different ways to do this. I want to say, I'm not sure which one we've been using in class. You can use the one we're going to use today is the image data set from directory. There's also several other methods. There's a few other methods as well, but that's the one I'm most familiar with and have done more experimenting with. So I'll walk through exactly what this code's doing as I write it up. Oh, just need to show that. So for starters, I'm going to want to punch in, I'm going to want to, one moment. I want to put that somewhere where I can. So this right here is essentially what the path is. So when importing files, if you're ever curious about exactly what import statement to use when you're looking at something new, so from TensorFlow, because this comes from TensorFlow.keras.preprocessing. Import image data set from directory. Oh, I can't use tab complete on that. Oh, I misspelled TensorFlow. How embarrassing. Okay, and don't worry about the warnings here. There's a couple of packages I need to tweak. It's not actually going to impact anything here. So now that we have this, I'm going to be creating a training data set and also a validation data set. And for each of these, I'm going to need a couple of things. Okay. So first up, for the image data set, I need to specify nope, that's not the one I was looking for. I have another set of code on another screen so that I can reference it as I'm going. So I'm going to be putting some hyperparameters here as I go. First, directory. And the way I'm writing things out, I'll explain once I'm through this block of code. So for the directory, this is where the files are stored. So on my machine, it's here. On your machine, it may be elsewhere if you're downloading. And because it's Windows, when I copy directories, I need to change which way the slashes are pointing. So if I recall correctly, yes. So I'm essentially saying that this object here is equal to, or the directory for the training images is here. And I'm going to also append one additional thing, and I'll explain in a moment why I'm doing this, because this might look a little bit silly. So I'm assigning this string right here, which points to where the image is stored on the machine. Next, there is label mode, which here is going to be inferred with, categorical. I was getting my some of my parameters confused because there is 4 separate categories here, which define the case. It's not, these are not, while they are sequential, I'm not using numerical numbers for these or ordered. So there is each class is a separate category. Next parameter is batch size, which for right now, I'm going, well, right, I skipped. Okay. I know this looks a little bit weird, and I'll show you in a moment why I'm doing it this way. So again, just pointing to that variable. Batch size, I'm going to do the exact same thing. And for this, I'm just going to put 32, and we'll experiment more in a moment. Once we have that, image size. And this one I'm going to do just slightly different. Okay, so the images here are not exactly 256 by 256, but this is going to crop them. And to explain, the images in this data set look like grayscale images if we look at them over here, but they do actually have 3 channels for red, green, blue on them. So we need to specify that there are 3 channels. However, here for the training data, it doesn't, when it's asking about image size, it's not asking about channels. So I'm going to go image size, again, referencing here, but I'm going to call a slice from this variable and only select the first 2 elements here. And then the last parameter is going to be seed, and in this case, seed just means what seed is used for the random state. So, do the parameters that I've used thus far make sense in this?
Yeah.
Okay, so it may seem kind of wonky for me to put all of the variables here and then point to them right here, right below. Now we have this for the training set. I'm actually just going to copy this, and this copy is going to be called the test data set. And I'm just going to change this variable to point to the test folder, and voila, I've now made my test data set. And if I need to make any tweaks or adjustments, I can make them right here, and the change will take place right here. Oop, I missed. Let me see. Oh, whoops. And I misspelled categorical again because I can't spell. Voila. And so it even puts a quick summary. 5,121 files are in the training set for 4 classes. 1,279 are in the test set with 4 classes. So far, everyone with me? Okay. So now that we have the data loaded into the data set, which by the way tends to be the hardest part of any deep learning project, in my personal opinion, because you have that's where you run into the most obnoxious of errors. Now we're actually going to build the model. And so have you guys all finished the week 2 material on great learning?
Yes.
Okay. If not, that's fine. It's not just would change how I'm explaining certain things. Okay. So now I'm going to create a model right here, and I'm going to go with a very basic one to start, and then we'll kind of work into more complicated ones like we did in the previous study session. So layers dot conv 2D filters equals, and let's start kind of simple on this. So 64 filters. So there's going to be quite a large image coming out of, or a large dimensional image coming out of this. Let's see if I can remember all of the parameter names. Let's go 5, 5. Activation equals relu. And nope, I have to double check something. Input shape. And now we're going to call image size, which is right up here. Okay. And let me see if, let me check that parameter. Must be valid or same. Okay. All right. And I'm going to have a second layer. And this time we're going to go down to 32 filters, curl size 3 by 3, activation, relu, and padding equal same. Okay, now that I've had 2 convolutional layers, what's the layer that I need next? Or if I'm going to change from convolutional layers to the next type, what should I do next?
The pooling layer.
Okay, max pooling is an option. So actually, let's avoid max pooling for right now. I want to save that for the next part. What do I need before I can start doing classification?
Oh, the dense layer.
Okay, so we have dense layers are required. And for that, I'm going to need to define how many units there are. Picking a number arbitrarily. Okay, and another one I'm going to need, let's just assume we're going to have 2 dense layers, one for classification and actually to make this just a little bit more interesting. One second, I want to see something. So when possible, I like to, instead of putting actual integers, put something in here that references what the size is supposed to be. So for instance, here, instead of writing out the image shape or image size, I had it listed right here. So I could reference the same variable there, and then I can change things more easily, or change everything at once more easily. So I don't always remember what this variable is called, but the data set itself has a variable for the, okay. So right here, training data has .class names has each of the classes listed. And if I just use the len function, I can actually get the number of classes. So I'm just going to do that. And so units, because the final layer has to have the same number of units as there are potential classes, I'm just going to call this right here to pull that up specifically. And since it's the final layer, I have to use a sigmoid activation because, well, sigmoid or softmax for classification. Now, looking at this right now, we have one other thing missing. What do you have an idea of what it might be? So we have the convolutional layers, which are taking 2-dimensional images, well, 3 dimensions because there's channels, and performing matrix multiplication and convolutions on these to extract features, but we still have a three-dimensional image. Can we feed those directly into a dense layer?
I would say no.
Correct. Do you remember what you have to do in between to get to prepare it for a dense layer?
Mhm.
Okay.
Let me think. Just when I thought I had it.
I'm trying to make sure I have audience engagement here.
Ah.
Because realistically, I'm knowledgeable about some of this stuff. I can code a lot, but if you guys just want to hear a lecture, there's better ones on YouTube than me.
I know, right? No, just kidding.
Oh, don't undersell yourself. Yeah, I wouldn't know.
The fully connected layer, but that doesn't come until the end though, right?
Nope, the dense layers are the fully connected layers.
Then I am like, I don't know.
Okay, so one thing that you can do, you guys can't see it on your screen, but every time I go up to change one of the tabs, the drop down for Zoom keeps popping in the way.
Yes.
Let me just make it so that I'm using everything except the last like inch of the screen. Okay. So if I go over here to the TensorFlow API, I can actually see there's the tutorials right here. And if I go to the image classification tutorial, I can go down and look and see how do they build their model and what looks different with theirs than mine. And if you go here, you're going to notice this layer right here, flatten.
Oh, yeah.
And what this does is it's just a reshape function that takes the image and moves it into one dimension. Yeah. So voila. And you can also look here and see. I'm going to steal this line. That was one of the things I was going to look for later. Okay, so I can actually go here, and now I know layers dot flatten, and that will give me, oh, comma. Did I forget another comma? Nope, I misspelled kernel size. Did I do it here as well? Nope. Oh. Okay. So right now we have a simple, and I did this backwards, a simple, relatively simple neural network structure here that we've made from scratch. So the next thing we need to do is train the model, and I know you guys have, I don't know if you guys have seen me use this in previous sessions, but oh wait, we have to compile the model first. Whoops. So model dot, if I can press one key at a time, compile, and for the optimizer, let's pick Atom, because Atom tends to work perfectly fine for the majority of use cases. It's not always the best, but it works just fine. Oh. And we're going to use categorical. Let's see if I can spell it correctly this time. Cross entropy. So in the previous session and on the previous project, we were using binary cross entropy. Categorical cross entropy is when you have more than just one or two categories. So instead of being an either or, it's now multiple. So you need a slightly different loss function. And for metrics, let's see what metrics we can use here, because we're going to have accuracy, but accuracy by itself is not going to be enough. So you guys, does it make sense to you that sometimes accuracy is not a good metric for a problem?
Yes.
So in this data set, we have 4 different classes, but the majority of cases belong to non-demented or mildly demented. Moderate dementia and extreme dementia are rarer cases. There's less entries of them. So if the model predicted everyone as being as not having any dementia, it would have a very high accuracy by default, which is not good enough. So we're going to want accuracy score, but I'd also kind of like to include something a bit more robust. And so the one that I used before was the F1 score, but I'm going to see. Let's see, categorical accuracy is what I'm going to use categorical accuracy for just so I have an accuracy metric. And then I want as my other metric, I just want to see what other ones they have here. They have a lot of options. I wonder if accuracy under curve will work for multi-class classification. Yes, but I'm going to need to adjust something. Okay. So, not the right one. Okay. And okay. Let me see if that, yes, that should. Okay. So now, in addition to having accuracy, I'm also using area under curve. And so this is the rock curve, but it's going to be taking an average across each class. So yes, finally, I want to add callbacks before I train the model. You may have seen in the previous, if you saw in the previous study group, I used early stopping as a callback, which I'm going to use again just as a time saver. And let's do. So essentially what I'm doing here is I'm telling the model if it continues, if after multiple training cycles, it's still not improving properly, to stop early and restore the best weights to the model. Okay. And And so we're going to fit the model. We're going to go with gotta remember. Make sure. Oh, I put it as test data set. And just want to see another thing real quick. Oh, I guess I didn't name them data set. Silly. Okay. Okay, so while this is going, and okay. How's it going, Lonnie? Oh, I'm sure he'll hear us in a moment. Let me check something else real quick, because that's taking longer to load than it should. Fascinating. Let me stop that right now. Move that line. Weird. Okay, so to explain what is weird to me here, normally that is a longer training time that this data set should really be using. So I'm trying to figure out what have I done differently here that would explain that training time.
Did Lonnie leave us?
It looks like he dropped out. It may be he is having connection issues. He wasn't making any noise, so it's possible he was having sound issues and is restarting. So let me try something else real quick. Welcome back, Lonnie.
Hey guys, I got the time mixed up. Sorry about that. I was thinking 6 on Tuesday and 5 on Monday.
Quite all right. Okay. Did I not? Okay. Okay, wait. Maybe that's not the one I was looking for. Interesting. It would appear that this is not using my GPU right now. Fascinating. Okay. So let me make sure this is saved. I'm going to restart Jupyter Notebook and see if that fixes it. Oh, yeah, okay. And we close out of this real quick. Just restart Firefox entirely. Okay. What did I save this as? Did I not save this? I thought I saved it. Practice it. Okay, right there.
Hey, where do you check the system performance in Task Manager?
Task Manager is the one I was looking at. I was trying to check. Why is TensorFlow not recognizing my GPU right now? Weird. Okay. But yeah, I was pulling up TensorFlow, or I was pulling up Task Manager and just looking at performance. If I really wanted to get fancy, I have some other options as well. I have MSI Afterburner and also HWI or HW info as well on my machine. Let me see. Getting some GPU utilization right now, just not from this. Strange. So let me see. Okay. I don't think that's going to fix it, but let's just try something. Kernel. Oh, so run all. Okay. Check. That is. Huh. Give me one moment. I might have to reboot my computer to fix that.
Hey, did you have to add any CUDA environment paths or anything like that? I know I joined late, so I might.
Oh yeah, I shouldn't have to. I didn't have issue with it on previous sessions. Just curious why it's not showing my GPU. So I'm going to do a quick Google search. Okay. Let's copy code randomly off the internet because that's always safe.
Remote code executables.
Yeah. Wondering if there's something I was supposed to update at some point. Well, I know there's things I'm supposed to update. This was working, or I wasn't using this specific one before, but when I was working with tabular data, I believe I was using the GPU, and I believe I ran this line of code and was able to pull up my GPU specifically. Okay. Error after October. No change there.
So you didn't start on any of those updates that you were thinking about earlier in the week?
Nope.
Right? All right.
I should have. Ugh. That is somewhat unfortunate. Well, I guess I'm just going to have to change the environment that I'm running this in for right now.
Are you thinking that it'll just take a long time, or do you specifically have to use the GPU for this?
Well, I don't have to use a GPU, but just to show you for me comment the comment this out for now. Kernel or cell. Run all.
I didn't have the extra $380 to give to Apple to get an external GPU. So I don't know how it would help me right now, but I'd be glad to look back at it once I do get the funds.
Oh, that's because I still have that there. So just to show, if I were to run this here, it's going to show that it's going to take that long to execute on a CPU. And if instead, let me load.
This is the milliseconds, correct? Or is that minutes
Nope.
and seconds?
That's minutes and seconds. So if I go over here, this is, so I did essentially, I wrote a notebook up yesterday to practice with and to make sure that I corrected any errors before I got into the study session. Because ultimately I want the study session to be about helping you guys work through errors and clearing up any confusion. And I'm just gonna change these parameters. And yes, that looks, well, run all. And this one is running on a GPU. So you'll see in a second what the time difference is. So you'll notice the ETA on this was a minute starting out. This one's still at 6 minutes. And so there's a pretty significant time difference there, but I was ultimately hoping to use my own computer's GPU because the GPU I have on my computer is better than the one that they use in these cloud services. But c'est la vie, I'm just gonna have to restart and do some tinkering to figure out what was going on there. Ooh. Okay, it looks like I lost someone. How unfortunate. So now that we've gone and just created a simple model, I know you missed a couple steps there, Lonnie. Does anybody have any questions? I guess Will's not at the computer right now.
No, I'm good to go.
Okay, in that case, I'm gonna let this run for a while. So I also noticed when I went onto the Great Learning Forums earlier, and I noticed you had a question about loading the data set.
Oh, no, that was before our session on Saturday.
Okay. So just to check, were you trying to load it as a notebook?
Yeah.
Okay.
That's what they had. That's what the file type was. And so it took what, nanoseconds almost to find out that wasn't going to work.
Ah, okay. I was curious if that was the mistake, was what came up. Okay. So to explain what I'm doing over here is I changed. Right now I'm running this in a cloud environment. This is a Jupyter notebook running on Kaggle's server. And as I'm running the model, you can see down here that the accuracy is moving from starting at the first epoch at about Welcome back, Ramiro.
Sorry, my computer died.
Happens. So to explain what you missed, I'm running into some sort of issue here with TensorFlow not recognizing my GPU. It was in previous sessions, so I suspect that I'm just going to need to restart my machine, but I'll test that later. So instead, I decided to switch over to this cloud environment, and so I'm running the same notebook right here, but on Kaggle's server.
Okay.
And it looks
how
like.
Would, sorry about that.
Go ahead.
I was just going to ask, like, if something like that would have happened to me, like, how would I have known the difference?
So me seeing that difference is because I've used, I ran this notebook last night on Kaggle's server when I was setting it up because I was working on my Chromebook instead of my computer. And so I knew how long it would take on Kaggle. And I know that on my machine, I have a much nicer machine at home than the free resources that are available on Kaggle. And I'm not knocking Kaggle's resources because
Mm.
they're very generous in providing those free to the community. But I know on my machine it should be quicker. So the first thing I did was I just went and troubleshot to see, okay, is it not loading on my GPU? And that's when I realized it wasn't registering that I had a GPU.
Okay.
Not sure why.
Yeah, I guess that's the other questions. How do you resolve that?
I'm going to be restarting my computer next to after the study session to see if that was the cause of the issue. After that, I will probably, if that still is insufficient, there's a few other things I'm going to try. So I just want to see. Okay. We go. Oh, I don't want to move back to. Oh, that was too much. Did not know I could stretch something to be across both windows simultaneously. Okay. Nope.
Do you have a Logitech keyboard or a mouse? Logitech?
Yes.
Yeah, they Logitech has built-in what they call Flow or something like that, Logitech Flow, so that you can canvas across multiple monitors.
Yeah. I just didn't expect it to go full screen on both monitors simultaneously. Okay.
Hey, there's a class called Resource within Python, and I'm not sure if these are just for virtual resources or something like the local hosts OS resources, but maybe there's something in there. There's some get R limit and set R limits. Then here, let me see if I can. I'll go share this link. See if you find it valuable at all. But I'm just thinking, when I was a coder, like, I don't know, 10, 15 years ago, that something, and on the Windows side, something like Windows sysdernals was helpful, as much as people knock it. I like knowing that when we have memory leaks, and it looks like maybe some of those tools may be used for this, but I'm not sure about allocated hardware.
Well, I have a few hypotheses about what it might be, but I want to. Well, let me check one other thing. Nope, that's still the right version. Anywho, doesn't really matter. I can use this online tool for it just fine. So if you're looking at the training data right here, I'm gonna graph this in just a moment. You'll notice that this one is overfitting pretty wildly. see if that. Oh. Did I not import pandas?
Neil,
Yes.
you said that we could see that it's overfitting. How can you tell that?
You'll see in just a second. I got a little bit ahead of myself.
Okay.
I expected I was going to crank. What is? Oh. Okay. Nope. What is not happening right there? Okay. Using all skill. Okay, good. One of them. Alrighty, so got a little bit ahead of myself there, but you'll see in just a second what I'm talking, how it overfit. Because otherwise you'd have to try and read the tiny print off my screen. And okay. Let me just do one other thing. Okay, so if you look here on, this is what the training looked like. So we've got the blue line refers to the accuracy on the training data, and this orange line right here refers to the accuracy on the validation data. Notice how there might be a slight issue here.
Yeah, totally. I mean, I see that now with the graph, but
Yeah.
But you saw it ahead of time by just looking at those numbers. So I was wondering.
Yeah, because I can see right here, the accuracy here, or categorical accuracy refers to the accuracy on the training data.
Okay.
Validation categorical accuracy refers to the accuracy on the test data. And in fact, it looks like it really hasn't improved much at all.
I see now.
So let's step over here and make a few changes. So And let me see if I got that right. Nope. What? Okay. Oh, max pool 2D. Doy. Sorry. Not the right one. Pool size, that's what it is. Actually, I wonder if I don't, since that's a positional argument, if I can just pass in that. Let's see. Okay, so before I run this again, I just want to show you that notice how it took 1 minute for the first epoch and then 30 seconds about for each epoch after. We've added 2 max pooling layers here, but otherwise left this exactly the same. So let's try running this again and see how it affects the training time. And I'll spoil, I don't know how it's going to affect the training time. I know it's going to lower some of the computational complexity because we have these pooling layers which are downsampling the images as it goes. Oh, wow. That's interesting. So you can't necessarily read it off your screen because while streaming it, so I'll just kind of summarize it for you. This time the accuracy started for the training data at 44%, and at the third epoch has risen to 65%. However, on the first epoch, the accuracy on validation started at 61% and has been not moving a huge amount, but it's moving in a positive direction. So we will see if this overfits. Sorry, the categorical accuracy started at 51% and is now it's sine waving. Okay. Okay. Yep, and now
Not
it's
waving anymore. It's flatlining.
Yep. So while that continues to flatline a bit, I'm just going to write a new function down here for the area under the curve. Back. Okay, I'm going to give it just 2 more epochs. And you'll notice now it's taking less than 20 seconds per epoch now. So much quicker because we added the max pooling.
What do we call this when the categorical accuracy is overtaken by the training data accuracy?
So you're
Is that
talking
what
about
was happening?
one moment. Oh, I guess it didn't save that because that didn't finish all the way. Boring. Well, I guess I'm probably going to change this to 10 epochs. So when the accuracy on the training data continues to rise, but the accuracy in validation starts to fall or sine wave, that means that the model is overfit. It's it's trying to find signal that isn't there anymore, or it's adjusting to signal that isn't genuine. Does that make sense?
Yeah, it does. That last line changed right before it stopped. And it may have just been an anomaly in the calculation. That's really what I was asking about, where it looked like the categorical accuracy was higher than the I'm sorry. It looked like the training data's accuracy was higher than the categorical accuracy for a moment there, and then it went back to the way it is.
Sometimes that can happen because of a fluke occurrence. Just weights tend to just happen to move into some perfect position for it. In many cases, it means that you're working with a very noisy data set. So I wouldn't worry too much about it initially. It tends to mean that you might have more clean data inside your validation set than training, just because of the nature of the split.
Good to go.
Okay, and then I want to go over here for a moment because I want to see experimental. Where is it? Keras.experimental. Nope, that's not it. Layers.experimental. Pre-processing. Okay. So I'm going to add one more thing. Actually, I don't need a whole new line for this. So let me see if I remember. What is the whole thing here? So see, not what I meant to do. I saw it in the example notebook and I just wanted to see if I could find it. Nope, this is not the right one. One moment, I need to see. Because I saw a piece of code in one of the example notebooks and I want to just kind of, yes, okay. So right here, this is the piece of code I like. They were showing that there was a method for rescaling data in as a layer. So me first. So it was from, oh, if I can get just one keyboard at a time. Sorry, one letter at a time. Okay. And then here, so what I'm essentially doing here is rescaling the input images, or one of the input images, but I also want to see. Let's see if I can load one image real quick. How did they do this in the example code? Okay, they use pill. Interesting. Yeah, I guess I'll use that one for right now. Sorry, I just want to, well. Okay, so we got one image there. Let me see. Interesting. Let me change something right here. Sorry, now this is kind of boring at this point. Oh. Oh. Interesting. It would appear that there actually is only one channel in this. Strange. Give me one moment to check one more thing.
Why does it show 1 of 10? I mean, one epoch for 10 input?
So that's epoch 1 of 10. So it's going to, this is the second epoch, this is the third. So it would continue going.
Total.
By the way, before I dive any deeper, does anyone have any questions or anything they need explanation on? Okay, so I just want to check what normalization to use. So I want to see what the scale is of the images. I want to, actually, I think what I want to do is open it as a NumPy array. I don't know why they're showing. Okay. NumPy.asArray. Okay. And I'm just going to let this finish running once just so I can show, so I can test one other thing. And it'll be finished in about 25 seconds. Okay. Okay. So if we look again, we can see the model is once again overfitting. In training, the training data keeps improving its score. The testing data doesn't really improve much. Just make sure that this ran. Okay. Did that? Nope. What? Okay. Oh. Okay, so it does go all the way to 255. I wasn't sure. So if I go back here, I'm going to add as a pre-processing step rescaling, and this will rescale the data by dividing it by 255. So the max value can be 1 for the data, and the minimum value can be 0. Let me just see. And for this, I need to have, actually, why am I doing it that way? That should be fine. Do. Oh, that's the interesting. One moment. Okay. Huh. So something here is affecting the input shape. Let me see, is there anything done differently in this notebook that I'm missing? Nope, doesn't seem to be. And just to make sure I'm not, well, that might be crazy. Let me comment this out and see, or just put this in as this and then change the necessary hyperparameters. Not
Yeah, it's perfectly
hyperparameters.
safe to say that you're not crazy. We don't have a trained data set for to compare it against. Or test data set. There we go.
Okay, input 0 of layer conv 2D is incompatible with layer blank. Expected number of dimensions 4, found 3, full shape received. Am I? Huh. And no, because that works just fine. Fascinating. Oh, well. Well, before let me comment that out first and try a different one. Another approach I want to try. Well, there's other things in that specific module I wanted to try. So let me try something else. So I'm going to do something called data augmentation, which I'll explain as it's training. Okay, random rotation. And will that, okay, good. So what I'm doing now is something called data augmentation. This is using the same package as this rescaling function. And I just want to see if there's something specific here that was causing the issue, but there isn't. Data augmentation is a method for getting more out of a smaller data set. So essentially what it does is it will, at each batch, when it calls its set of images, it will feed those images through a pre-processing step where it will make changes to those images. So in this case, it's just random rotation. So the image itself will be rotated slightly. And the idea there is that a rotated image is functionally carries just as much information as a non-rotated image. So you're presenting the same information from a slightly different angle so that the model can absorb more information from it. And the idea behind that is that it keeps the model from overfitting on specific areas of an image. Does that make sense?
Mm-hmm.
Okay. So that is running just fine. While that is, let me see if I can just go in here and pull up. I was using rescaling. Let me take that argument out and see if that was something that was throwing the issue. And you'll notice now we're getting, we were able to get a slightly higher area under curve, but our accuracy is not really improved. So this really didn't help much or at all, really. But there's a lot of things you could do. There's rotations are a common way to do it. There, sometimes you'll flip or invert an image. There, other methods you can try are, one moment. Oh, and that finished. There is, oh yeah, that is all over the place.
Looks like the bat signal.
Yep. And you can see the same right here. In fact, actually, we look at it, the area under the curve is better in testing than on the training data. I want to change something real quick. Okay, so gonna see, does this affect it? No. Huh. Okay. So now we're gonna rescale the images before feeding them in. And let's see how big of a difference this makes. So starting accuracy is at 48%. Starting area under curve is at 51%. And the categoric or the validation accuracy is marginally higher. The validation area under the curve is significantly higher. And while that's going, I just want to double check over here. Do we have? Okay, not seeing anything. And it looks like the accuracies also stayed about the same for the test data. So the test data, it's still not moving much. I think for the last thing I want to do is I want to try a slightly more complex design. So we're going to use more units in the dense layer. But first, I'm just going to finish this one up because it's mostly finished as is. Oh, it's actually improving somewhat on the test data. Oh, I spoke too soon. So now to see again.
So why do you think you're having these problems, these issues?
Truthfully, I don't know.
Okay. And the only reason I ask is
So
if I were doing this and I got this data, I wouldn't know what to do.
So when I come into issues like this, and actually I'm going to set up the next training batch, because notice how I'm seeing those come out and I'm making adjustments here. So I'm going to try making a slightly more complex model to see if I can fix the issue. And we'll see
Danielle,
if
I
that
need to
takes.
drop off.
Go for it.
But thank you so much. See you guys.
Yeah.
Hey, see you, Will.
So when I come into issues like that, where I'm seeing overfitting, there's a lot of ways you can look at that problem. And most of the time it comes down to adjusting the complexity of the model, or lowering the learning rate, or any number of other changes.
Mm-hmm.
However, this particular data set, you're always going to have some level of trouble with, because it's a small data set. There isn't a whole lot going on with it. That being said, you can get much better accuracy out of this. So just to see if we can bump this up a bit, this isn't exactly cheating, but I'm going to look at what I did to get better accuracy when I was using Fast AI. That's not the right one. So let me see. All right, let me see what parameters I used. I was using size 224. I don't think that would have a big impact, but we can always try that.
Wait. What do you mean size 224? Where?
Oh, right here.
Oh, I see. Okay.
And then all right. So we go up here. Again, I don't necessarily suspect that's going to change much, but just in case, that's one option. And then I used VGG16, which I'll explain in a moment. Okay. So up to now, with the exception of going into data augmentation, everything I've shown is stuff that we've done in class. I'm just showing the code for how to do it and make it a little easier. Just checking over here at these scores. Okay. So now let me do something a little bit more complex to show you guys something more useful in computer vision. So what we've done so far is we've trained neural networks from scratch to fix these problems. But sometimes you're going to wind up in situations like this where you're using a small data set. Actually, I'm going to run one more experiment. Sometimes you'll run into smaller data sets like this, where you just don't have enough data to adequately train a model, or maybe you just don't have enough data on a particular class, And so training one from scratch doesn't make sense, because realistically, to get a high performing model, you want to have 10,000 or 20,000 or more images to train a model from scratch. And you want ones of a reasonable size and quality, which these aren't. In total, there is 2,000 images in the training set, which isn't a whole lot.
I see.
So the next thing that you can do to improve model performance is something called transfer learning, which I'm kind of surprised they didn't go over in the class, and I'll show you in just a moment how to implement. So transfer learning is think for a moment. It's when you have one model that performs very, very, very well and has been trained on a very large data set, and then you take everything. You take everything before this. So you take the flatten and dense layers off that pre-trained model. You move that pre-trained model onto the new problem and then add custom flatten and dense layers to it. So essentially, what you're doing, so essentially you have that pre-trained model that's been trained on a very large data set and has learned the parameters there, and then that's facing it, and then you move it to a new data set. Because realistically, for many use cases, the same convolutional filters will have value for other problems. So the common one, typically what you see are popular architectures that are trained on what's called the ImageNet database. And ImageNet contains over 1 million images in it, and I want to say 1,000 different classes. And the models that are trained on ImageNet tend to get around a 90% accuracy after full training. And that training takes days using traditional methods. There are ways you can accelerate that to be 4 hours or less if you use some fancy methods. But really, it's, oh, this one didn't overfit. What did I do different? Oh, right, I used a sigmoid function instead. Fascinating. Still didn't capture all the complexity. Essentially what you do, essentially then that pre-trained base of a model does not get trained again or gets very lightly adjusted. And then all that's getting changed is the only thing that you're training is the dense layers that have to learn those functions. Does that make sense?
Mm-hmm.
Okay. So I'll show you how to do that.
Okay.
So let me.
Actually, I'm gonna have to sign off as well.
Okay.
But,
I'll leave a
go ahead.
link then for how to do that training.
Sounds great. Thank you.
Thanks.
Neil.
Yeah, thanks, Romero. Thanks, Neil. I have to drop too, so I appreciate all of this.
All righty. Well, it's been 2 hours, so that seems like a good amount. I'll post the video to YouTube with some additional links on how to do transfer learning and its benefits, as well as the code for this section. Thank you guys very
Cool.
much for your time.
Well, thank you.
Thank you as well. Have a good night.